Good day, distinguished participants, and good morning, afternoon, evening, depending on where you have joined us from today. We want to welcome all of you, especially on behalf of Professor Tina Haley, to the third day of our workshop. Yesterday was very interesting, exciting. We learned a lot, and Professor Sedakwa is available today to take us through the third module, and then we'll bring you the fourth module, hopefully on Monday. And in 2 weeks' time, we'll also be bringing you another session, but that will be looking more into article writing, issues of publication, and what to know, the ins and outs. Professor Sedakwa will bring that to us as well. So I'll hand over to my co-moderator, Ms. Irene Duffier, and she will just give us a few words and then continue the moderation. Thank you, Irene. If you can hear me, please take over.
Yes, thank you, Kwesi. Good day to everyone. Thank you, Prof, for joining us today. It's a pleasure to have you once again. I know that yesterday was amazing. Yesterday, the interactions. And so we are asking again that today, let it be like that. We should interact when the questions are asked. We encourage all of us to give our comments, to give our experience, to share our experience. And we are here again with our able facilitator, Professor Nana Osaida, with us here. Prof, welcome once again to today's Friday session. And we know that it's going to be excellent, like how it was on Monday and then yesterday too. And so we look forward to an exciting presentations and conversations with the group. We've muted ourselves because we want to prevent background noise from joining. So if you would want to answer or share any comments, please use the raise hand button. We would unmute you and then we will let you talk. If you also want it to be simple for you, you can put it in the chat. Whilst going on, we'll read it. If it's a question, Prof would answer from there. If it's a comment too, we'll read and then we'll digest whatever we have. And so we wish you a fruitful session. Prof, over to you, and thank you so much for joining us.
Okay, thanks a lot, Irene and Kwesi. Welcome to our third session. Based on the outline, today we're going to focus more on sampling issues and measurement issues. Again, we may not be able to cover all aspects of the topic. I'm always interested in the interactive part where you share your experiences, with us, so that we can also learn, from you, as well. So that would be our approach for today. At the end of the presentation, of course, you have access to the slides. So if we are not able to cover the slides, don't worry at all, because you have access to it as well. So on this note, let me share my screen, with you, and then we'll take it from there. Okay. There's no way we can cover the entire research process in 4 days, as I said. So what I've done today is to try to make, 2 of the sections. This is very familiar to most researchers. We all do sampling and stuff like that, and we all do measurements as well. So, let's look at the outline. So this is a very simple outline. What is sampling? Some terminologies, we're not going to cover all of them, just selected ones. Because sampling, there's a whole semester course on sampling. So, in this limited time, there's no way we can cover all aspects of it. 2 main types of sampling, so we look at that, and then we shift to notion of measurement. What is measurement and the levels of measurements, and how do we evaluate measures. This leads us to the notion of reliability, validity. This should be very familiar. We look more at examples from your research. There are always some difference anytime you measure. The difference is what researchers call error. So what are the sources? And then we talk about standardized measures, as well. So that's our roadmap for, for today. because the last 30 minutes is always Q&A, where we share. Now, let's begin with the research process. This was part of the slide that was sent to you, day one, even though we couldn't cover it, just to put the discussion in context. If you're a researcher, you know all these steps to be able to, put together a proposal. You need to go through all these different, steps. First, you need to identify the issue of interest to you. This is what researchers call, the research topic or the research problem or whatever it is. And then after that, chances are that you're not the first person researching the topic. Others have done it before you. So what do? You go to look at what others have done, and that is reviewing the literature. What do we mean by that? Is where you undertake a concise overview of the literature in a given area, your area of interest. What has others done? And what's the purpose of the literature review? The purpose is to know what others have done. The purpose is to know how they did it. The purpose is to identify gaps. And the purpose is to help you fill in terms of your own area of research, because what do you want to do? You want to contribute to the state of knowledge in the area. So if people have done it over and over again, what are you contributing? How do you undertake a literature review? Generally you search. You look for what others have done. There's a bunch of stuff out there. There's no way you can search everything. So after searching, what do? You select. You select the best ones that will inform your research objectives or your research focus. And after you select, what do? You extract. You extract from the literature that you've identified. And after you extract, what do? You package. You package it in a format that you could use. These days, thanks to the role of technology, there are various sources of literature review. In the good old days, we all go to the library and, read books and, look for databases and stuff like that. These days, there are a bunch of journals. Most of them are online. There are a bunch of conference proceedings we could use. There are a bunch of books we could use. There are a bunch of websites. There are a bunch of dissertation databases, research databases, name it. You have access to all this information. So the challenge is always, what criteria do you use for selecting these materials? It's based on the number of factors. Most researchers recommend relevance. To what extent is it relevant to what you're doing? They'll recommend currency, meaning that it's not dated. Even though in some areas, especially, some theories were published in the 50s and 60s and 70s, they are still relevant. So we still use them, we still cite them, but the more recent the publication is, the better, because knowledge is not static. Knowledge changes over time. What's the scope? What is the length? I know sometimes people have asked, you don't have to read everything. It's impossible, actually, to read everything in your area. So you pick and choose what is relevant. So sometimes some universities may have their own guidelines, for guiding their students when it comes to reviewing their literature. What do you look for when you are reviewing the literature? You look for study goals, you look for how the study was done, this is the design, you look for the findings and stuff like that. You always have to have what I call an organizing framework when it comes to reviewing the literature. Sometimes people will use what they call the topical order, where they organize the literature based on main topics or issues. Sometimes people will use what is called the chronological order. This is where, based on the year of publication and the time of publication, and then they will select, and then, they will use it. So there's a bunch there, because of time, we couldn't really get into much details about the literature. That's why I decided to give you a general overview of what the literature review means. Then based on that, people will state their research questions or they'll formulate their hypothesis, because now they know what is out there. They have identified all the gaps. Always remember, the literature review is not a mere listing of the literature. It is a constructive critique of what is out there. And out of that, then you also decide on your design. Your design is always what? Your blueprint for undertaking the research. How are you going to undertake the research? So is it through survey research? Is it experimental research? Is it content analysis, qualitative? There are a bunch out there. So you decide, again, based on the goals of your research. And then you go to the field, you collect your data. How do you collect your data? It could be self-administered directly to the subjects. It could be through interviews, it could be computer assisted. There are a bunch of options as well. Now that you have the information, how do you make sense out of it? This is data analysis. So you go ahead and you analyze your data depending on the focus of your research. Is it qualitative data analysis? Is it quantitative data analysis? Our last session, Monday, we'll look at data analysis and stuff like that. And after you analyze your data, what do you do with what you have? You interpret your report, you publish, you present at conferences, and stuff like that. So generally, the processes, involved. So to summarize, the research process, identification of the topic or problem, reviewing of the literature. When you get to the study design, the research design, the data collection, this is where sampling issues come in. You need to select the population of interest. And then you also need to measure the key concepts, the key variables of interest. So this is where measurement comes in. So our focus today is on sampling and measurement. Of course, yesterday we talked about ethical issues in research, the fact that ethical issues are crucial, the fact that ethical issues cuts across all aspects of the research study from beginning to end through the research process. And we went through a historical journey, we cited several examples, we identified the key ethical issues and stuff like that. Of course, you analyze the data in your report. So this is just a background to what we are going to do, today, just to give you focus and to give you, direction. So let's start with our first activity. We're talking about sampling. What is a sample? And I want you to give practical examples of sampling known to you. We do sampling in our everyday life. We may not call it sampling, but that is what we do. So why, in your opinion, are sampling methods used in most studies? So let me stop sharing and let me solicit your views on what is sampling, and especially give practical examples in our everyday life, and then why sampling? Why do we use it? So let's have a short discussion. The floor is open now. You can raise your hand. Irene and Kwesi will call you, or you can put your response in the chat. I want this to be as interactive as possible. If you're a researcher, you've gone through this process before. How did you do it? And stuff like that. What is your general understanding of sampling and practical examples of sampling, and why sampling, and not something else? Let's have a short discussion. We're waiting for your comments. You can put it in the chat, you can raise your hand, and then we'll take it from there. Okay, somebody gives an example. When cooking, say soup, you stir, then dip a spoon and taste to see if you have enough salt. That is a good practical example. You know, the issue is that you don't drink the entire soup, right? You just dip your hand and then you stir and then you taste. So why do you do that? You do that because you feel that that small portion that you taste will give you what? Futures of the pots of soup. Okay, that's a very good example. Okay, sample differential research from census. You know, that is true. But what is a sample? We haven't defined that. Okay, there are numerous examples that you can provide. And that was a good one from AB Bio Awutwa Efabo. I hope I'm pronouncing your name right. Forgive me if I torture your name. Any other examples that you can think of? Numerous examples. Okay, a sample is a representative from a whole lot. It's a representative from a whole lot. That's a good perspective. You know, something that is selected to represent a whole. Okay, good notion of a sample. Any other example that you can think of? Sample is a subset of a general population, okay? Practical example is selection of my respondents that will participate in my study. This is done because it is not feasible to include everyone in the study. Very good, from Ngozi, you know. So you select a subset to represent the whole because it may not be feasible to study everybody for various reasons, and we'll look at some of them. A group of people, objects taken from a large population. Example, postgraduate students from students' population. That's a very good example from Julia. It's a group of people, objects taken from a large population. So it's like a part of a whole. Okay. When the national exams is given to students to represent learning outcomes. The national exams is given to students to represent inner learning outcome to show their direction and also the outcome. Okay, in the pharmaceutical industry, essays are carried on samples, okay, to represent the whole batch. No need to say the whole batch. Another fantastic example from Arnold, you know, especially in the pharmaceutical industry. They take a part, you know, they don't test everything. The assumption is that whatever part that they test will give them properties about the whole. A number of observations from a population. Okay, great. The sample is a true representation of the population used in data collection. That's great. The sample is characterized as a representation of a whole from a part. Fantastic. It can also be defined as random subset of populations selected for research study. Great. These are great perspectives. It's only that the examples, only one came, but that's okay. At least you get an idea of what a sample is. All right, let me go back to my slides and then we can look at some of the issues out there. But at least the idea is there. We've defined a sample, practical example, one has been given. And then, in your opinion, are sampling methods used in most studies? You know, why are sampling? Okay, so good. Okay, these are some examples. A sip of coffee, tea, or cocoa, or whatever you have. You know, in the morning, some of us have to have it. We would have what? We make a cup of coffee or a cup of tea or a cup of cocoa, you know, and then we will sip. We don't drink the entire stuff to be able to determine the properties. You know, sometimes I want to make sure the sugar mixes, rice, milk, and stuff like that. So it's what we take a part of a whole. Sometimes we go to the store, and we want to shop. And then, my daughters are a good example. They love shopping, so sometimes we go out there, and they don't even look at the price tag sometimes because they know that is going to pay for it, But of course, for most of us, we look at the price tag on the clothes and it gives you an idea about all the price tags, depending on which section that you visit. So you say, this is an affordable store, this is a very expensive store, and stuff. Sometimes you enter a store, you look at the first price tag, you say, get the hell out of there, and stuff like that. So again, it's part of the whole. Bathtub experience, for some of us, especially, in our part of the world, or especially in the West, because of the cold temperature, you want to take a shower in the bathtub, so you start mixing hot and cold water, right? Before you jump into the bathtub, you don't just jump into the bathtub and start screaming, oh my God. You would dip your hand, to make sure that the temperature is about right. So again, is what? A part of the whole. The assumption here is that that part will tell you or give you properties or information about the entire water in the bathtub. We go to stores sometimes we go to wine or food tasting festivals. They'll give you a small glass of wine to taste. And then when you drink it, the assumption is that that small glass of wine that you tasted will give you information about the entire wine in the bottle. You don't ask whoever is there that, please, I need to drink the entire wine before I can decide. Even though quantity makes a difference, on the food and stuff like that. You go to a grocery store, they introduce a new type of food. They'll ask you to taste it. And then on the basis of that, you make a decision. Are you going to buy or what? All these are practical examples. So each of these examples indicate that a small sample can tell you a lot about the whole. See, that's the whole notion of sampling. That is why I said we do sampling in our everyday lives, almost every day. We may not call it sampling, but that's a fact, and that is what we do. So what is a sample then? A sample is some part of a larger body specially selected to represent the whole. Sampling is a process by which this part is chosen. So taking any portion of a population or universe as representative of that population or universe. So again, the goal is that that part reflects similarities and differences found in the total population. Again, remember that the main objective here is what? Pulling this part is to make what we call inferences about the larger population from the smaller sample. So it means the sample has to be well selected. You are not interested in that small part. You are interested in that small part in order to make inferences, statistical inference, to infer that whatever in the sample will reflect characteristics among the population. So here's the process. You have the population, you have a sample. You cannot study everybody, as one of you said. So you pull a subset of the whole. So you pull from one. So here, for example, you have maybe 3 different colors. So you pull one, you pull a second, and then you pull a third. So you have a sample drawn from the population. So the goal is that that small sample, the 3 guys or whoever, or reflect characteristics of the entire population. That's the whole notion of sample. Okay, let's continue. So we talk about sampling theory. Theory means that a small set of observations, or what we call sampling units, we'll get to the terminologies in a second, can tell you about the larger population. There's a whole notion about sampling theory. A small set of observations can tell you about the larger population. Why sample? You know, one of you said you cannot study everybody. Why? Because of what? Feasibility. It's much, much easier to pull a sample. It's much, much faster to pull a sample. It's less expensive than asking the entire population. You know, so may not be able to find all members of the population. Sometimes some population are difficult to identify. So pulling a sample or subset helps a lot. So these are some of the reasons why, you know, we sample, because of some of these reasons. There are other factors as well which may influence our sample representativeness. Sampling procedure is a type of sampling. We'll talk about that. Sample size is always an issue. You know, how many people, how many respondents, and stuff like that. And then participation or response. Researchers are always interested in their response rate. You know, but there are certain circumstances where it may be necessary to pull everybody when your population is very small. You know, for some areas, it's very difficult to identify. You know, that is why we use certain types of sampling. We're going to get to that. You know, when you have extensive resources, sometimes, you know, it's a question of time. If you have the resources, you know, you can pull a larger sample. When you don't expect a very high response rate is always key. You always want to make sure that you have adequate to do whatever analysis. So sometimes it may be necessary, you know, to sample almost everybody. These are very factors. Closely related are two key factors: precision and homogeneity. Precision is how much sampling error is acceptable. Remember, you are using what? A part of the whole. If I have a class of, let's say, 30, and I want to determine the mean age of the class, the population there is 30. I may not be able to sample all of them, so I pull a part of the whole. There's always a difference between the sample mean and the population mean. But you want your sample to be as precise as possible. So there are two related terms: confidence interval. It always falls within a range which contains the true population value. We've seen all this pooling. Anytime they pool X number of people, you know, they will say that within a certain range, plus or minus 3 or plus or minus 5 or whatever. You know, that leads to the confidence level, degree of certainty that the population value is within that confidence interval. I use the example of 95%, meaning that if we did this study 100 times, 95 out of 100, we will arrive at the same conclusion. We can trust this. 95 out of 100, you know, is very, very high. The level of homogeneity based on what you are studying is also a factor. The more variability in the population to be sampled, the larger the sample required. You know, if your population is very, very heterogeneous, you know, then you generally need a larger sample size because you want characteristics of your sample to be reflected among your population. A population where most members are alike can be estimated over a smaller size sample. For example, if I'm interested in studying the homeless population, we know that they are a fairly homogeneous group. You know, homeless population, most of them lack a place to stay. So you see them all over the place. Most of them are unemployed. there's a high level of mental illness among them. Most of them lack resources too. They are very, very identical. You don't really need a huge sample size to study them because they're fairly, homogeneous group. But if it's a highly heterogeneous group, then definitely, in order to get the characteristics of the sample to be reflected, or the population to be reflected in a sample, then you will need a larger sample size. Precision and homogeneity, these are factors that we need to take into consideration. Now let's do another activity. There's what we call a sample. We talked about that. There's what is called a pool, and there's what is called a census. What's the difference between a sample, a pool, and a census? Let's have a short discussion. A sample, a pool, and a census. What's the difference? Are they the same or not? They are all interrelated. We know that. But what's the relationship? So sometimes we talk about pooling, sometimes we talk about census, sometimes we talk about sampling. You can raise your hand if you want to speak, or you can put your response in the chat. There's a message from Abiodun who says, do we call it sample and sampling and that research method while using the whole population? That is what we are discussing now. Definitely, if it's the whole population, we cannot call it a sample, because a sample is what, a part of the whole. Okay. Any response? The relationship between a pool, a census, and a sample. Somebody says they are different. This is Abdallah. Yeah, we know they are different, but how different are they? That's what we're asking. For example, what's a pool? What's a census? Of course, we know what a sample is. So what's the relationship between a pool and a census and a sample? Abiodun's hand is up. Maybe Kwesi, you can give him access. Or Erin?
All right, Abiodun, please go ahead. Hello, Abiodun. You're muted. Please proceed. Hello, Adesina. Okay, so Prof, there are some feedback in the chat pod. Maybe you could do that whilst we wait for Abiola.
Okay. All right. I see ABC sample the subset of the population. Census is the whole population. That is great. Exactly. Census is the whole population. When everybody is included, we call it census. Census is targeting the entire population participation research. That is great. Not sure, but I would think a census aims to include every member of the population. Cecilia, you're right about that. Polling is like voting. Census is enumerating a group in respect of their different characteristics. Age, gender, employment also involves counting. I mean, census is always based on some demographics. So, I mean, you're right. But the key here is census is everybody involved. Research should be done through sample. Effective about the relationship between a sample, a pool, and a census. These have been around for a very, very long time. Now let me go back to my screen. and then we can take it from there. So the issue was the relationship between a sample, which we know, a pool, and a census. A poll is a type of sample dealing mainly with issues of public opinion or elections, or people's attitude about candidates for political office or public issues. You know, anytime there's an upcoming election, you see all these polling organizations. In Ghana, I don't know if there's a known polling, even though I know sometimes there are some agencies who may conduct some poll. But in the US, you know, the example that I know, we have the Rupa poll, we have the Harris poll, we have the American Institute of Public Opinion, we have the National Opinion Research Center. They will be conducting polling just before, you know, election. And then, you know, people tend to trust the outcome because to a very large extent, you know, they tend to predict the right outcome of the election. Even though recently, especially in the context of the US, you know, there have been some issues in terms of the numbers. The last election was between Trump, you know, and Joe Biden, even though almost all the polls predicted that Joe Biden would win the election, but the margin was smaller than predicted, you know. So it's based mostly on election. This is polling. A census is a survey in which information is gathered from or about all members of the population. And all these techniques have been around over 2,000 years. I mean, remember those who are Christians, the story of the infant Jesus, they travel to be counted. You know, those days it was decreed that everybody should be counted. So they have to travel so that they will be counted. That was a census. That was organized. And this is more than 2,000 years ago. So these techniques have been around for a very, very long time. So that's a relationship between a sample as a part of a whole. A pool is a type of sampling, but it deals with people's, you know, opinions or election, or people's attitude about candidates for political office. You know, sometimes they are, who would you vote for? You know, candidate A or candidate B. You know, Ghana had an election recently, and I know there was a bunch of polling around just before the election. There were all kinds of predictions. You know, there are some polling that may not be scientific. You know, especially, you know, pastors. They have a tendency that they have received revelation, you know, from God, and that this person will win. Sometimes they change their position. That is not scientific. But, you know, it's an element of polling as well. They try to predict the outcome of an election. So that's the relationship between the three. There's no way you can talk about sampling without dealing with some concepts, you know, in sampling. These are just very selected concepts. You know, remember, I've been talking about population and the sample. Population is almost everybody, you know, but it's highly theoretical because at any given point in time, you know, part of the population may not be available, you know, so that is why it's called population or sometimes target population. And then the survey population is just an operationalization of the target population. You know, is the target population with some exclusions and all that. So example, the population accessible, including those outside, you know, the country. Element is always a unit of analysis, you know, what is studied and things like that. Sampling frame is one of the key elements we need to understand. It's just a listing that we pull from. So here, you see you have your population, you have your sampling frame, and then you have your sample. So that's a relationship between a population, sampling frame. The sampling frame is always a list of the elements in the population, and you select your sample from your sampling frame. Okay, so this is just an example. So you have your sampling frame. At the same time, you have your target population, which is like opinion of Ghanaian adults on current politicians, but then your frame, you don't have phone numbers of all these adults in the country, and then, but you can access a master frame of all available cell phone numbers, which you can use a technology called random digit dialing. You know the prefix, and then you just dial, and then somebody's line rings, and then from there you select your sample. Sampling frame is always, one of the key issues to look at, for it narrows the target population to the actual list of sample that you select from. So that is how it works. Okay. Sampling error is always a difference, as anytime you pull or anytime you use a sample to reflect features of the population, there's always a difference. The difference is what researchers call error. So, and then sample size is the number of people that you eventually select. Sample design is a type of sampling that you use. Sampling bias is the fact that your sample may not be representative or may not reflect characteristics of the entire population. Margin of error is always a difference, or the level of precision needed, by the researcher. There's always a difference. That is why we use the word confidence level and confidence interval. Okay. Now, let's do another short activity. People have been very predictive when it comes to polling over the years, but there have been some major polling mistakes. The question is, kindly discuss a situation where there was a major polling mistake in the prediction of the outcome of an election, from any part of the world. There was a major polling mistake, and that formed the basis for some of the sampling techniques that we're using today, because researchers made a mistake and they predicted that a candidate will win in the long run, that candidate lost. So any known polling mistake that you can remember in any part of the world, in your part of the world, it could be in Nigeria, maybe people said, candidate A will win, and then candidate A lost. Any example that you can think? We're using that to make a point. Anybody? You can't think of any sampling mistake or polling mistake. Okay. Well, let me share one with you then. And this occurred in the US. This is way back. And then it became the basis for refining most of the sampling techniques that we are using today. Where from this stuff? Okay. So some of you might have heard about the Literary Digest. The Literary Digest was a magazine, which was an organization at that time. This was in the 1930s. In the US, there was an election between London and Franklin D. Roosevelt. I don't know where this polling is coming from. Let me close this stuff. So this was in the US. There was an election between, and this was what they predicted. London will win, like 1,293,000, all that. And then Roosevelt will win 972,000. That was their prediction, those days, in the US. But then what happened? The question was very simple. Who will you vote for in the upcoming presidential election? between landing and Franklin D. Roosevelt. So they sent out 10 million surveys. Remember, this was in the 1930s. Those days, survey was, they were using the post office. So they sent it out to 10 million people. And then they predicted that London will win 57% of the votes. But the actual results, when the election outcome came, Roosevelt won with 63% of the vote. This is Franklin D. Roosevelt, who eventually became the president. And Franklin D. Roosevelt became so popular because at that time the country was going through a lot of the Great Depression, and he introduced the Social Security scheme and a bunch of social intervention programs at that time. So that was a big mistake. This is a map of the US. Blue states are Democrats, red states are Republican states. D. Roosevelt was a Democratic president, and the landing was a Republican. So the question here is, based on the discussion so far, what do you think went wrong? I just want you to speculate. They made a major mistake, predicted that Landing will win over Franklin D. Roosevelt. They sent 10 million surveys in the mail. This is 1936. And the actual outcome was the opposite of what was predicted. So the issue is, what went wrong? Okay, there's also, AB also gave an example, which was also true. In recent time, American poll indicated that Clinton would defeat Trump, but it turned out differently. That is another great example. Great example. We all, read it at that time. So somebody said wrong sample was pulled. AB, wrong sample was pulled. Okay. Again, remember, we are not interested in the sample. So how you select the sample is key. And AB is saying the wrong sample was pulled, which is one of the reasons why. Okay, Nigeria polling votes do not count. Okay, after elections for good candidates, we end up with the wrong leaders. All right, so that is Faith's opinion on that. There was sampling bias. Sampling bias. So that was also one major reason. Sampling bias, meaning that those who were selected were not representative of the entire population. That is key. Sampling bias. Okay. Biasness of sampling. Okay, sampling bias, yes. Okay, so it means that in selecting the sample has to reflect characteristics among the population that you intend to generalize. That is why generalizability is key in sampling. But to use a type of sampling which we are going to discuss, then it means that the sample has to be selected very, very well. Otherwise, you have a sampling bias, and then that bias does not reflect characteristics of the population, and you end up with this outcome. Majority of the people did not have post addresses, maybe, which is true, Catherine. They used a mail, 1936, not everybody had access to that. It leads back to the idea of sample bias. The sample was biased. All right, so that is great. That is great. So at least it gives us an idea that in selecting our sample, we have to be very, very careful to ensure that. So again, the sample drawn from telephone directories, club membership, magazine subscription lists, all of which were luxurious during the Great Depression. Remember, 1930s was when America was going through. It started in 1929, actually. It was only wealthy citizens who could afford to get the survey because they had access to, a mailbox, and not everybody had access to that. Again, it goes back to sampling bias. Also look at another reason. 10 million sample, 2.4 million responded at that time. Sometimes you think that it will be a lot, but response rates, remember I mentioned response rate. Response rate was only 24%. That was very, very low. So we should keep that in mind as well. Okay, so we all get stuff in the mail, and sometimes we don't even look at it. We just throw it away. We have no time, and things like that. So generally, response rate and the fact that the sample was biased. Okay, so let's keep this, at the back of our mind. Anytime we are polling or we're doing sampling, we should be mindful of representativeness and response rate. These are key things that we need to keep into consideration. So sample was not representative of the population. Respondents were not representative of the sample of the population. Survey failed to accurately predict election outcome. A classic example of bias impacting research. These are the key reasons why, it led to that outcome. Now, in the case of Hillary Clinton versus Trump, people have given all kinds of reasons, why, even though sometimes when you ask people, who would you vote for? Because at that time, the image of Trump, so they would say, I vote for Hillary Clinton. But in actual fact, they were going to vote for Trump. People have published several articles on why the outcome was like that. So the whole notion of probability theory and sampling distribution is based on that. The notion that the sample has to be rightly selected. If the sample is biased, it becomes an issue. Okay, so we should always keep that, in mind. All right, let's do another activity here, sampling types. Kindly identify the two main sampling techniques known to you. That's the first part of the question. But most importantly, kindly share with the class the type you've used in your research and the reason for its selection. Most of us have written proposals, we have collected data, we have published articles, and we always state a type of sampling that we use. So what type of sampling did you use, and why did you use that kind of sampling in your research? So I'll stop sharing and let's have a short discussion about that. What are the key sampling techniques known to you? What type are you familiar with? What type have you used? And why have you used that? I want you to share your experience with the class.
All right, so if you want to speak via your microphone, please click on the button with the hand raised and we will enable the microphone for you to speak. You can also put your comment in the chat pod as well. All right. Maybe, please go ahead.
Hello?
Hello, Ibi, on mute? Yes.
Can you hear me now?
Yes, you are audible.
Yeah, we can hear you. Yeah.
Okay. Now we have random sampling where we selected people randomly. We have clustered sampling, but the one that I use most of the time is purposive sampling. You always set up criteria for selecting the sample. That's purposive sampling.
Why do you use purposive sampling and not the other type of sampling?
Because we had some criteria that we are looking for, and only the people that met those criteria were chosen.
Okay. Okay.
If you want me to example, if you look at people, let me just use an hypothetical example. If you want to look at people
if it's a
please?
research project, you can talk about the project as well.
Okay.
That maybe you research this and you use purposive sampling because they made a criteria and the study was about this and all that. You know, just share some information about the study.
All right, let me pick that of Adesina. Adesina, please go ahead. Adesina, you're muted. Please go ahead. Hello, Adesina, are you there? All right, Prof. So we have some comments in the chat pod. Probably we could look at that.
Okay. I know Christiana is saying probability and non-probability sampling methods. That's great. You know, these are the two main types of sampling. Pussy says purposive sampling to purposely target subjects with in-depth or vast knowledge of the phenomena and the study. These are key informants. We visually okay, keeps on shifting and stuff like that. Yeah. Okay, so that is well stated. Outdoor purposive sampling information take enrich, which is preferred. Okay, that's fine. It goes in systematic and non-systematic. Most times I use systematic because it gives people equal opportunity of being selected. This is good for generalizability of the results of a larger public. That's great. You know, and then purposive sampling was used because that's one where nursing mothers who will be asked through positive questions on the experiences during pregnancy as regard tetanus immunization. Thanks for sharing your research with us, Ayodele. That's great. Purposive sampling is common in life science research, okay? Probably based on previous background information and knowledge, which will serve as a lead to further research. That's great. This is one Biola. All right. And then let's see. Snowball sampling from Dennis. This is another type of sampling. We talked about that. Probability and non-probability sampling from Christiana. That's great. Purposive sampling to purposely target subjects with in-depth or vast knowledge of the phenomena and the study. These are key informers with visually vast and first experience. That's great. This is from Busi. Okay, this is great. So you have gone beyond even the question to state specific type of sampling. It appears purposive is very popular among most researchers on this platform. That's great. So we'll look at that in a second. So two main types we identify and shared why you use, a particular type, mostly, So probability sampling. Again, you've explained it already, so I'm not going to go into any details. So here, the key here is what? Random selection. And that the key here is that you want to ensure that everyone in your population has the same chance or an equal chance of getting selected. Okay, so this is based on what they call statistical theory to select randomly. So again, every element in the population has the same chance of being selected. So that's the whole notion of probability sampling. Okay, so again, these are further explanations and all that. So building on that, what is the logic of probability sampling, which I've actually explained already. So what are the types, as they currently identify the types of probability sampling techniques? We have different types of probability. So what are the types known, to you? You can just list it, you can just raise your hand, and we can just have a discussion on those. You said there are two main types which you have identified: probability and non-probability. Now we're talking about probability. What are the types of probability sampling known to you? Eric's hand is up. So, Kwesi, you can unmute him.
Eric, go ahead.
All right. Prof, we have a simple random sampling technique or procedure. We also have a cluster sampling. I think we also have systematic sampling as well.
Okay. So you mentioned three known to you: simple random, systematic clustering. Great. Christiana's hand is up.
Yes, Christiana, go ahead. Christiana, please unmute.
Sorry.
Great.
I said the last speaker had just mentioned simple random sampling, systemic sampling, cluster, and I'm adding stratified sampling technique, stratify.
Okay. All right, great. Thanks a lot, Christiana. So we've identified four main types. And actually, if you visit the literature, these are the four main types, which have been listed. So quickly, let's
There's
look
some
at
in
that.
the chat pod.
In the chat, okay. Let's look at that.
I think Dennis gives convenience sampling.
We are talking about probability.
Probability. So he gives that probability.
Yeah, so we'll get to that, Dennis, in a second. So for now, I think we have systematic stratifying cluster from Solomon. We have stratified some from Caroline and stuff like that. So that's great. And that's what the literature, I have identified. Okay, simple random, systematic stratified. This is from Ngozi. This is great. So let's look at, what we have. And again, this is what the literature has identified. So we just quickly, since we have already identified them, so I don't wait too much time. Generally, there are four main types, which I have mentioned already: simple random, systematic, stratified, and then cluster sampling. Sometimes they call it multi-stage or single stage or whatever stage cluster sampling. So these are types of probability sampling, So again, it's the same definition. Each element in the population has the same chance of being selected. And all these are types of probability. So simple random, as the name implies, it's very simple. So here you have a sample, and then you simply select, So the first simple random, you have your sample here, and then quickly you select out of that. It's as simple as that. Sometimes they use what they call a random table of random numbers. So I want to select a sample of 10 out of 100 or whatever. So I number all of them 1 to 100 with the help of my table of random numbers. I select 30, 67, 70, 21, 62. And I have my sample size out of my population. It's as simple as that, So that's that. Quickly, let's move on. Systematic sampling you mentioned, sometimes called interval random sampling. It's all the same. Again, the goal here is what, or the keyword is systematic, systematic. So again, we all call it equal probability of selection method, all of them. It gives each element in a population same chance of being selected. But here, you start with what is called every cave element, or every 10 person, every 12 person, every 5 person, is selected. That is why it's systematic. So it looks like this, so you have your population, and then, you select number 3, number 6, number 9, so here every third person is selected. So that's why they use every cave person is what is selected, or every nth person is selected, whatever number you prefer. So again, this is just further explanation how to compute that, and these are just examples of how it is actually done. Every 5th case is selected. So here you can see names of people and the addresses and things like that. Every 5th person selected. So it's as simple as that. And this outlines the steps involved in doing that. In the interest of time, we're not going to go into any of these details. So let's keep that. These are all ways to, to help you select your sample. So let's continue. The key thing to note here is sampling interval. That's the standard distance between elements selected. So every 5th person is selected. So number 5, number 10, number 15, that's your sampling interval. And then your sampling ratio is just a proportion of elements in the population that are selected. If I have 100 and 110, it's 1/10 of my sample, which will select 100/10. That gives me my sampling ratio. It's as simple as that. Okay, so let's keep all, these are all additional explanations, of that. So we have stratified sampling. So again, it's different from systematic. Stratify is putting people in what? Subgroups, smaller subgroups. For some populations, sometimes it's very difficult if you use simple random sampling or systematic sampling. You have to put them in smaller groups. Sometimes people use examples of faculty. If you want to look for certain characteristics among the faculty, you have to put them in subgroups, males and females and whatever features that you are interested in. And then you pull from the subgroup. So that becomes, stratified sampling. This is just an illustration, of that, and this is how it's done. So again, you have women, you have men, and then you pull, the characteristics. All these are examples, illustration of how it is done. I'm not going to waste much time. All these are examples, especially in the West. Race is always an issue. So they look at Black, they look at white, they look at Asian, Hispanic. Put them in smaller groups and they select, from those groups. All these are, sometimes there's a discussion among what is called proportionate stratified and disproportionate stratified sampling. Proportionate is where you pull the same proportion from each subgroup. Disproportionate is where you oversample, because sometimes even with proportionate or even with stratification, you realize that certain elements may still be underrepresented. So that is why you do disproportionate stratified sampling. Then the 4th one we discussed is multi-stage cluster sampling, where you do it in stages. Stage 1, you select maybe census. Stage 2, you do this, stage 3, and stage 4 before you can get to the actual population. This is an example. I use the US example. So this is the whole country, US. Randomly select the state, of interest. That would be stage 2. And then you select census tracts from each of these states. And then you make random selection of blocks within each tract. And out of those random selection of blocks, you get to households. The key here is that it is done at what stages. That's why it's called multi-stage cluster sampling, because some elements may be very, very difficult to reach, and the best way to reach the population is to use multi-stage cluster sampling. And this is just an example. Stage 1, random select states. Stage 2, random select cities, towns, and counties. Stage 3, random select dwelling within each of these areas. Stage 4, random select individuals within each dwelling. It's done in stages. Now, we've talked about probability sampling, and the other side of the coin is what? Non-probability sampling. So the question here is, what is non-probability sampling? Can we identify the types? I think you've already identified some types. In the interest of time, let me just skip this activity. Let's move on. Generally, in the literature, you will come across 4 main types of non-probability sampling. The first one is convenience sampling, or sometimes called accidental sampling, or sometimes you see availability sampling, or sometimes you see haphazard sampling, or you see opportunity sampling. It all means the same. And then you see judgmental or purposive. I know most of you are familiar with purposive. That is what we use. And then there's snowball sampling, and there's quota sampling. All right, let's try to understand quickly. These are all examples of non-probability sampling, because there's no way that you can guarantee the inclusion, of your respondents in the sample. It is impossible to determine or to develop a sampling frame, and things like that. Certain populations, that's the best way to study them. It's cheaper, it's easier, but it has what? Limitations when it comes to representativeness, because there's no way you can document or you can guarantee who is part. So degree of sampling error is always what? Unknown when it comes to non-probability sampling. Convenience sampling, that is why it has all these names. You select them for convenience sake. Sometimes we go to the mall, and then you'll be there, and then somebody will approach you. You happen to be there at that time. They call it accidental. By accident, you find yourself there, so you got included in the sample. It is haphazard because, you are haphazardly selected. So all these are parts of convenient sampling. There's a good example. Hey, do you believe in a death penalty? This is somebody who is going his way. Somebody stands somewhere and shouts. It happens that the person was passing through, and then he got included in the sample. So that is how it is. It's convenient because it was there at that time. Judgmental sampling, you select people, is also called purposive. You select them for a purpose, as you clearly explained, because you feel that they have the features that you are looking for. So you select them. The best people can respond, to maybe your instrument. So you select them for that purpose. So this is just additional explanation and additional examples. Let me skip that for now. The next one is snowball sampling. Sometimes you may be studying an issue, it's very difficult to get the people. So when you identify some of them, then you can ask them, do you know of other people who are interested in this? I know when I was a graduate student, some years back, I was involved in a study where interested in studying caregivers of Alzheimer's patients. At that time, it was very difficult to identify the respondents. So we went to an Alzheimer's support group. They gave us referral. Some agreed to participate in the study. So we visited them. We interviewed them, gave them a questionnaire. It was a qualitative study, very in-depth questionnaire, because we're interested in finding about their caregiving experiences. After we interviewed them, so we asked them, do you know of other caregivers of Alzheimer's patients who might be interested in participating in this study? And some, they give
Gracie.
Hi, Irene.
Yes, can you hear me?
Yeah, I can hear you.
Yeah, is Prof still on?
No, he's on, but
Okay,
yes,
I think he
I think
just left.
he's just gone
the-
off.
Yeah,
Yes.
okay. All right.
So you'll
Let's
be back
try
shortly.
getting him back on. Yeah. Mm.
Okay, so no, he's not back here. All right, let me call him. Okay, so Prof will be joining us in the next 5 minutes. So in 5 minutes, Prof will join us. Okay. So I think Irene, hello. We can take this moment for our break, maybe in the next 5 minutes. If you want to stretch, you can stretch so that when Prof comes back, we will not go for the break session. Irene, is that okay?
Yes, Kwesi, it's fine. Thank you.
All right. Thank you very much, everyone. So we can take our break for the next 5 minutes. And when Prof comes
Kwesi,
back,
the break is 10 minutes, so we'll be back
10
at
minutes.
1:30. Oh, Prof is back.
Okay, perfect.
Kwesi, I think you have to make Prof the co-host. Yeah, so he can unmute.
Yes, now.
Okay, can you hear me now?
Yes,
Yes, Prof, we
Prof,
can
we
hear
can
you.
hear you. Please
Oh,
go
okay.
ahead.
Yeah, sorry, I think my power just went off, but it just came back. So, yeah, these are some of the challenges we have to deal with. Anyway, so I was talking about non-probability sampling. And so we covered, the four main types of non-probability sampling. So the fourth one is quota sampling. Quota is where people are selected based on certain characteristics of certain profile. So that is that. And this is a summary of both probability and non-probability sampling. Probability sampling, we have simple random, we have classes sampling, we have systematic, we have stratified. And then non-probable, we have convenience, we have judgmental, purposive, we have snowball. And then we have quota sampling. We can have a short discussion about the different types. And then after that, we can take a short break. So any questions, any comments, any contributions on any of the sampling designs? We all know that there are two main types. And, some of you use probability, some of you use non-probability. If given the reasons why you use probability or non-probability sampling, based on the reasons that we have assigned. So any general discussion, any general comments on any of the types of sampling, before we can, maybe take a short break and come back, and then we will continue to move on to other aspects of sampling, and then quickly we'll transition to measurement issues, and then we have our general Q&A session.
Ngozi, you said that you posted a question. Can you, I'm allowing you to speak. Kindly unmute yourself and ask Prof the question, because I think it's gone up and then we are not going to see it. So Ngozi, if you can hear me, I've asked you to unmute. Kindly unmute and ask your question to Prof. Go ahead,
Hello.
please. Yes, we can hear you.
Can you hear me, please?
Yes, please, go ahead.
Okay, yeah, I posted a question asking the acceptable sample size. How is it going to be drawn from a larger population? What is the acceptable sample size? Do we have any guide that will help somebody to select a sample size from a large population that will be representative of that population? Because we need to take this into consideration when we're talking about generalizability of the result to the larger population.
Okay, actually that's the next thing we're going to talk about, but generally, they have statistical guidelines actually for calculating the right sample size based on your area of interest or the population of interest. There's something they call the law of large numbers. Generally, the bigger the sample size, the better. Again, remember the examples that we gave with all the biasness. 10 million surveys were sent out, 2.4 million came in. That was only what, 24%, response rate. So the sample size was not adequate. Okay, so there are all kinds of statistical methods for estimating adequate sample size, but we're going to talk about some of the factors influencing sample size. Then that's the next discussion that we're going to have to wrap up our discussion on sampling. So generally, that is how it is. There are methods for estimating. I don't know if anybody, the statisticians among us can help us. They have tables, they have mathematical formulas actually for estimating. Sometimes they talk about, effect size and, that is the presence of a phenomenon that is being studied and its impact on the null hypothesis, and stuff like that, which also affect sample size, because when you increase the sample size, it also increases the effect size. But we'll talk about that in a second. That's the next discussion we're going to have before our quick break. So we'll come back to that. Okay. And then some of the charts is multi-stage sampling technique the same as the cluster random sampling technique? Yes, that's why I say multi-stage cluster sampling. In some books, you see one stage, you see two-stage, multi-stage, depending on the number of times that you pull. So it is the same. Reverend is saying, please, do we have purposive, convenient sampling? I think if you look at the type of sampling that we listed, convenience is because you happen to be there at that time. That's why it's called accidental. That is why it's called haphazard and things like that. Purposive is sampling selected to achieve a purpose. You're interested in, for example, I did a study on this elderly, their attitude, perception about COVID-19. To a large extent, I used purposive sampling because the sampling was selected for a purpose. I went through 2 churches because I believed that, the churches were going to help me to get the right sample. And that is why I chose. I selected them for that purpose. The purpose was that I was interested in their attitudes and perception towards COVID-19. And then fifth is simply said with respect to business, and then be eliminated completely in a research. I'm not sure what you mean by, oh, biasness, sorry. No, you cannot eliminate. You try to be very objective in your research. This is what science asks you to do, objectivity and all that. But sometimes that is why even when you use a sample, there's always a difference, between the sample mean and the population mean. So complete elimination, we try to do that because science has to be what? Objective. So that is one of the issues that you have to keep, at the back of our mind. Try to remove our biasness, but sometimes it becomes a challenge. Can more than one probability sampling method be used? Well, definitely, it depends. And even in the same research study, sometimes people combine. Depends on the focus, of your research study. So it is possible. And people have done that. I've seen published articles, where they have used other types to supplement or to complement the other type of sampling. I see Eric's hand is up as well. So maybe Kwesi, you can unmute him.
Yes, Eric. Eric, please unmute and go ahead. Eric. Yes.
Thank you. Thank you, Prof, for your presentation. I think one of us asked a question, but I want to add. In reality, do we really do the simple random well, or let them say the kind of systematic where we obtain the kit term, where we obtain a list of our participants to determine every fifth term or every seventh term, or we obtain that list to actually randomly pick from it? Do we do that in reality? If not, is there a way to go about that? Thank you very much.
Okay. In reality, you are researchers. These are the sampling options. Probability, we've talked about the different types. So assuming you're using simple random sampling, do you use, a random table to help you to select your actual sample? Or, you guarantee that every element has the same chance of being selected and stuff like that. So it all depends on, how you implement these concepts in your research. If it's systematic, as you said, every key element, so do you number them, put them in a tables and say, okay, every few person will be selected, and then you select number 5, number 10, number 15, and stuff like that. So this is a general, question for all of us. Mabel is saying, I used random to select fishes for my investigations. Your comment status of fishes at the early yearly in one study. Okay, so random to select fishes in my investigation. What kind of random sampling was used? So maybe you can elaborate on that. In another study, I selected only women in a study on the fish production activities of female on Asijeri Lake. Again, maybe you can elaborate. Then Dr. Barringham is saying, in one of my studies, which focus on teachers and students' level of preparedness for computer-based instruction, I use percussive sampling to select the heads of schools for interview. Percussive is so easy to administer because you just select them based on the purpose of your study. And you describe it, but at the same time, when you are writing for presentation publication, you also discuss the limitations. I'm sure we're all familiar with limitations and delimitations, in research. Okay. So limitations are, the fact that you use this type of sampling, so it limits your ability to generalize and all. delimitations are factors over which we have control, over, and things like that. Okay. Any other comments, suggestions? If not, let me wrap up our discussion so that we can take a short break. And then when we come back, then quickly we shift to measurement in the interest of time, so that at least we can cover some of the slides and open it up. Okay, determining sample size. This is the question that, one of you asked. Sample size is so important. How many people do you select for a study? How big a sample is necessary for a good survey or a good study, and all that. It depends on a number of factors. The researcher's hypothesis or questions, population homogeneity. As I said, if the population is fairly homogeneous, chances are that they have the same features. You don't need a huge sample size. But then, so it's population homogeneity or heterogeneity. If it's highly heterogeneous, then of course you need a bigger sample size. The sampling technique used, probability, non-probability. If you are using non-probability sampling, to a large extent, you don't need a huge sample size. My daughter is writing a PhD, dissertation. I think her sample size is 25. She's interested in studying, people, women, Black women who've had prison experience, who have been released. She wants in-depth information about their prison experience and how they cope with child rearing practices when they were in prison and after they were released. And she's interested in finding out, has it changed? So in prison, what's the nature of the parent-child relationship after being released from prison? She wants in-depth information, so it doesn't need a huge sample size. So again, that is one factor, that we need to take into consideration. And as I said earlier, there are formulas for determining the right sample size. There are mathematical formulas for doing that. But these are general guidelines, factors, based on the nature of your study, and, which also helps to determine the type of sampling size that, you will need. How do we determine the size of our sample? How many cases are needed for the research hypothesis? Precision, how much error can we accept? These are factors: population homogeneity versus heterogeneity. As I said, the more variability in the population to be sampled, the larger the sample required. Sampling fractions, the number of elements in the sample relative to the number of elements in the population. If you have a huge population to select from, then generally, because of representativeness, you want to make sure that each element is represented in your sample, so you may have to pick a bigger sample size, for your study. And then this technique used, as I explained earlier, is also very, very crucial, in determining the sample size that you need. Generally, I talked about the law of large numbers. The larger the sample size, the better the estimates, or the larger the sample, the closer the true value of the population is approached. Again, I use an example of a class of 30. You want to estimate the mean age. If you use just 5 students, chances are that you may be off. But if I select maybe 20 out of that, or 15, which is 50%, then chances are that the sample mean will be closer to the population mean. So generally, the law of large numbers says the larger the sample size, the better the estimates, but it depends on the other factors which we outline: population homogeneity versus heterogeneity, the level of precision that we want to establish. All these are very great factors that influences, sample size. So I think this would be a good time. Let's see if you have any questions, and when we come back, then quickly we'll go through the other topic, which is measurement, which is closely related to most of what we do, because we all use questionnaire. We are measuring the key variables. We all use instruments, standardized instruments in our research, be it medical research, biomedical research, behavioral research, social science research. All these are very relevant. So quickly, we'll look at the key elements, and then we'll open it up for Q&A. Any questions before we take our short break? Okay, Mabel is saying the study was purposive. Only women who are fishing were selected, because I wanted to understand the activities. Okay. All right. If there are no questions, then why don't we, okay, I know Dr. Bahima hand is up, because he may be going to meet him. And then after him, then we can take our break.
Doc, please unmute, kindly unmute, please. Dr. Bariham, please go ahead.
Okay, thank you. Thank you very much, Professor, for the opportunity given us and for the quality training given us this afternoon. My question is, sometimes we hear these reputable international institutions carry out polls, sometimes related to political issues in a particular country. You hear them predict that so and so candidate A or B will emerge victorious. And at the end of the day, they don't get it right. Do we blame it on the data collection strategies they use, or we blame it on the sampling size they have taken, or the instrument they use in collecting the data? What will make a researcher not to get the polls right? Thank you.
Okay. All right, thanks, Doc. Yeah, it happens. That is why one of the earlier activities I asked, what are some of the, these issues where people predicted that candidate A will win, but in the long run, candidate A lost. What were the reasons for that? We saw the one, with the literary digest, because it was the biasness in the sample, and it was also the sample size, used. Now, research has established that anytime we pull 1,500, the margin of error is always between plus or minus 3. If you see most pools, you always see plus or minus 3. That is the standard statistics out there. If we pull 1,500, the margin of error or the level of precision, they will say 95% confidence interval, meaning that if they did the same pooling 100 times, 95 out of 100, they will arrive at the same conclusion. It's only 5 out of 100, and even within that, it will fall plus 3 or minus 3. So we can still trust that outcome. But yes, the type of sampling that we use is also an issue. If the sampling is biased, if you want to predict the outcome of an election, and let's say we have classes in society, and we all know that our interest varies. If you interview, let's say, fishermen, they have their own issues and their own preferences. So if all your sample is that particular population, definitely the outcome will be different. If you interview college professors, they have their own, biases at the same time. So representativeness is a key issue, in sampling. You see, there have been a lot of writing about Trump and Hillary Clinton, because most of the poll predicted that Hillary Clinton will win. In the long run, Donald Trump won. So people ask, what went wrong? One of the main issues was that people were not willing to come out openly to admit, that they were going to vote for Donald Trump. So when you ask them, because at that time, maybe the image of Trump was not very, accommodating or very positive. So to openly identify yourself as a supporter of Trump was an issue at that time. That is bias, at that time. And so people use that data, which is wrong data, to predict the outcome of the election. Of course, there have been other conspiracy theories, the Russians were involved and, and things like that. Up to now, there's no proof. It just remains a conspiracy theory, but sample size is key. Key is sample representativeness. If it's biased, there's no way that you can get the right results. Okay. So these are some of the issues we need. So that is why selecting your sample is always key. If you are using non-probability sample, that's a different ball game, because people know that it is not a representative sample. There's no way you can guarantee who should be included in the sample. So in your write-up, you always describe that you use a non-probability sample. This is not a representative sample. So in terms of generalizing to the general population, because, and I'll give you a good example. The research that I did last year on elderly African Americans, the general perception out there at that time was COVID-19 was disproportionately affecting communities of color. And then there were also other factors that people with a comorbidity status were more susceptible to having COVID-19. And we know among the elderly, as we grow old, we become more susceptible to all kinds of pathological conditions. They have, high blood pressure, they have diabetes, they have, name it, but my findings was different. I realized that, it was the opposite, because when you look at this, the profile of the respondents, most of them were highly educated. They own their own homes, about 90%, because one of the findings was that because of inability to social distance, and we know among low income, African Americans, of course, they have extended household composition, but among these people, if you look at how many people live in your household, it was maximum of 2, me and my spouse, because this is the empty nest stage. All the kids have left, so they are able to social distance, they own their own homes, so most of those factors, and they all have health insurance. So access to healthcare services, was not an issue for this kind of population. But maybe if it had been a different group of sample, the outcome would have been different. So all these are factors. That is why the socio-demographic profile of respondents is always key. Marital status, most of them were married. And we know that marital status is a key predictor of a number of factors. When people are sick and your spouse is around you, they'll take care of you.
Yeah.
Okay.
Prof, what about if you use inappropriate research instrument?
Well, definitely measurement. That's what we're going to talk
What about?
That is a major factor too.
Okay, great.
Yeah, if inappropriate research instrument, definitely, then it means the data that you collected, is biased. It doesn't really reflect, or the type of questions that you ask, the response that you get may not actually reflect the, what you are looking for. So definitely, yes, it is a major factor as well.
Good.
And we're going to talk about measurements and, the other areas around, around that. Okay.
I'm grateful.
Okay. I see there's one question in the chat. Assuming carrying out the research in Nigeria using geopolitical zones, southwest, which is of 6 states, is it advisable to just carry it out, the research sample within 3 states for one of the geopolitical zone? Will this be representative of Nigeria? Generally, the type of sampling that you are using is key. If you are using probability sampling and you have 6, states here, here you are using geopolitical zones, 6 states here, you collect data within 3 states. Are the other 3 states homogeneous? Are they similar to the other 3 states? Remember some of the factors that we mentioned. If it's a fairly homogeneous group, for example, if I'm doing research in rural Ghana, I know most of the futures in one village. It's not very different from other villages. So I don't really need to sample a bunch of villages. People in the villages have similar lifestyles compared to people who live in cities. So if that is the case, then you can make a justification for that. But generally speaking, 3 states may now reflect characteristics within the 6 states because the other states may be different. But if it's fairly homogeneous, then you can make a case. But if they are different, if it's fairly heterogeneous, then there's an issue right there. Okay, just like the Literary Digest, they focus on people who have mailing addresses. And this was during the Great Depression. It was a very small percentage at that time. So definitely they use a biased sample. So we need to take that into consideration as well. So again, it depends on the futures of the states. If they are similar, then you can make a case. But if they are very different, then people raise issues. Why 3 states and not the other 3 states? Are they similar or are they different? Okay, so that's my response in that. All right. Maybe this would be a good time to take a break. It's 1:50 GMT. 10 minutes break.
We'll be back at 2. Yes.
2. All right. Okay, so short break. All right.
Okay, Prof.
All right, thanks. All right. Let me welcome all of you back from the short break. At least I hope you've been able to stretch your legs or, just have a cup of whatever your favorite. Now, let's quickly shift our focus to this notion of measurement. Notion of measurements. Measurement is closely related to issues around sampling. For sampling, you pull a population. What do you need from there? You need data, whether in the medical sciences or physical sciences, we collect data. Sometimes we use what standardized instruments. We may have a ring gauge, it measures for rainfall. So, it's a standardized instrument. We have, a thermometer measures what temperature. And then we also have in the social sciences, there are what standardized instruments, So we use all this. Now, in research, we always use what concepts. What is a concept? I think we mentioned that very briefly. Something that we have in mind is a mental image. It summarizes our observations, our feelings, and our ideas. And leads the process of what is called conceptualization. Anytime we're engaged in research, we need to be able to define our concepts. That is the process of conceptualization. Conceptualization is like a dictionary definition. When you ask the question, what is? So we are asking for, sometimes we call it a nominal definition. But then to be able to use concepts in research, we need to be able to define it in such a way that we can measure those concepts. This is a whole notion of what we call operationalization. So there's conceptualization and there's operationalization. Conceptualization is asking for a dictionary definition. What is? Operationalization is translating those definitions into ways that we can manipulate in research. The whole notion of measurements, whether in the physical sciences or biological sciences or medical sciences, is all the same. Okay, so what is measurement then? Now, measurement generally is the process of describing abstract, concepts or, abstract concepts in terms of specific indicators by the assignment of numbers or other symbols to these indicators according to rules. If I have a questionnaire and I have a bunch of questions and I ask you, what is your gender? And I say 1, male. And I say 2, female. And I say 3, other. I have assigned numbers or numerals or symbols to these indicators. Because when it comes to data analysis, most of the programs will not be able to read male or female, but can read 1, 2, and 3. So the assignment of numbers or numerals to events according to rules. That's the whole notion of measurement. Okay, so we assign this in order to enable statisticians to be able to measure these concepts. All right. Now, in most of the literature, they'll talk about 4 levels of measurement or level of measurement. The level of measurement refers to relationship among the values that are assigned to the attributes of a variable. Remember, we talked about a variable and attributes. Gender is a variable. Variable is male, female, other. Religion is a variable. The attributes are very religious, fairly religious, not religious, or not religious at all. Political affiliation in Ghana could be NPP, NDC, PPP, name it. In Nigeria is a different story. In Kenya is a different story, and all that. So we assign these values so that we can categorize them in order for us to perform certain level of mathematical or statistical operation. The whole notion of measurement. The level of measurement allows us to measure variables at different levels. It allows us to determine what kind of statistics that we are going to employ at that level to measure those variables. 4 levels of measurement. First one is what we call nominal. It's just labeling. So when we say, gender, male, female, or type of shoes, it's just labeling. So that's what we mean, it's nominal. They're all at the same level. One is not different and start. I've given several examples, sorting a deck of cards into 2 piles, red cards and black cards, type of shoes and things like that. It's all labeling. So one category I like on some property, they differ from the obvious in other categories on that particular, property. So that's what generally it means. It's just labeling. Okay. And then examples here and futures. Each of these level of measurements has certain characteristics or certain features. So when we say a variable is measured at the nominal level, there are 2 main features. It's mutually exclusive and is exhaustive. When we say something exhaustive, it means that all the other options have been accounted for. I have a variable called gender. If I say if male assigned 1, if female assigned 2, if other assigned 3, it is what? Exhaustive. Mutually exclusive means that you cannot belong to one group and the other at the same time. So if you are 1, you cannot be male and female at the same time. That is what it means. They are in different categories, mutually exclusive. Categories must be distinct enough that no observations will fall into more than one category. So that is the 2 characteristics of nominal level measures. Difference is one of a kind rather than degree. You cannot say one is superior to the other. It's just a categorization schema that is done. Okay, so political affiliation measured as 0 is MPP. This is in the context of Ghana, the National Patriotic Party. So if MPP assigns 0, if NDC assign 1, if PPP assign 2, if other, there are other parties as well. I think in the last election, there were several parties which contested. So the other parties assigned 3. So this is exhaustive because if you are not MPP, you are not NDC, you are not PPP, we assign you 3. So it makes it also mutually exclusive. You cannot be MPP and NDC at the same time. So it cannot be 0 and 1. So it's mutually exclusive and exhaustive. That is what it means. These are nominal level measures. The next level is ordinal. You know, this is very elementary. We all know that. Again, it builds on the characteristics of the previous ones. So in addition to being mutually exclusive and exhaustive, categories have some explicit relationship among them. There's an order that is called ordinal. You know, there's a rank order. And there are several examples that we can give here. You know, if I say, what is your health status? Would you say 1, excellent, 2, very good, 3, fair, 4, poor? So you see there's a rank order here. So if my health is excellent, it's different from one who said my health is fair. So there's an order here as well. Or people who are running, you know, somebody comes first, somebody comes second, somebody comes third. There's a rank order here. So in addition to all those key features, so how would you rate your health? Excellent health, very good health, fair health, or poor. So there's a rank order here. So that gives you the next level of measurement. The next one is called interval. In addition to being mutually exclusive, being exhaustive, having a rank order. So here there's what? Equal distance, interval among them. So that is what it means. So this is the first quantitative application of numbers. Again, this is very important when it comes to analyzing your data, because if the variables at the interval ratio level, you need to know the type of statistic that you need to use. Remember, each of the statistics has its own assumptions. I think our last lecture will be on data analysis, which is going to be on Monday. And then we're going to revisit some of these concepts and demonstrate practically using a software so that you see how it goes. Okay, so again, example is the temperature scale, which is often used. Equal distance, temperature between maybe 40 to 45 is the same, like 45 to 50. The interval is 5 points. That's what it means. So uniform distance between them. That's the example that is usually given. So here you see that temperature of 75 degrees is 1 degree warmer than temperature of 74 degrees. Just as temperature of 42 degrees is 1 degree warmer than the temperature of 41. If there's equal, distance, between them. That's what it means. The last level of measurement is called ratio. Ratio is the same as interval. The only difference is that there is what sometimes they call it true zero, or there's a meaningful 0 point, or there's an absolute 0. And most variables, especially continuous variables, are measured at the ratio level. So that is what it means. These are examples: weight, area, speed, velocity. These are all continuous variables. These are all ratio level measurements and stuff like that. So again, each one builds on each other. So intervals and ratio skills are treated alike in terms of statistical tests that are applied. Now, you can always convert a higher level measure to a lower level measure. In the interest of time, I didn't build in activities, But if you have a ratio level measure like income, you can convert it to a lower level measure, like a nominal measure. If I ask you how much money do you earn, per week or per month, it's a ratio level measure. But if I ask you about your source of income, do you receive income from salaries or from wages or from social security or from pension? I'm interested in the source of income. Here it becomes a nominal level measure. There are several examples. So this is a table to illustrate. Nominal is attributes are only named, is the weakest level. Ordinal attributes can be ordered, interval, distance is meaningful, and then there is what? Absolute zero. Okay, each one builds on each other. You can always convert from the higher level to the lower level, but not vice versa. And as I said, in the interest of time, we didn't have, sometimes to people talk about skills, as I said in my earlier examples, especially in the physical sciences, and even the social sciences, there are a bunch of scaling. We talked about some examples. So this is just a summary, nominal, ordinal, interval, and ratio measures. So again, this is a summary table of the characteristics. So for nominal measures, it's exhaustive and mutually exclusive. For ordinal, it's exhaustive, mutually exclusive, and rank ordered. For interval, it's exhaustive, mutually exclusive, rank ordered. There's equal distance. And for ratio, it has almost everything, but it has what? True 0 point. So these are the features of each level of measurement. And this is very relevant at the data analysis stage and depending on the level of measurement of the variable, whether it's a continuous, categorical, dichotomous. Remember, we talked about all the different types of variables. Now, how do you assess all these levels of measurements? There are two ways to assess it. One is called reliability. These are all familiar to you. Measurements yields consistent results. So how do we assess reliability? Reliability means what? Consistency. Reliability means reproducibility of empirical measures. I always use the example of a scale. Some of us are conscious about our weight. So maybe in the morning in your bathroom suit, you want to weigh yourself. You get on your scale and let's say you weigh 80 pounds. You do it again, you weigh 80 pounds, you do it again, the next day you weigh 80 pounds. You can say this is reliable because what? There is consistency. You are able to produce the same score. So we can say that this is a reliable scale, and all that. So reliability refers to a measure's ability to yield consistent results anytime you apply it. Okay, so sometimes we talk about its stability, the idea that reliable measures should not change from application. Measure the same thing. We're going to talk about different types of reliability. We have what is called test inter-observer and inter-rater reliability. I'm sure some of you have used it. I was involved in a research study where we went out to collect data where two research assistants. One was asking the question and recording, the other was just recording. And then you just compare the results when you come back to the office to ensure what consistency. If there's differences, then there's a way to resolve it. Okay, so that's inter-observer and inter-rater reliability. There's also what is called the test retest reliability, where you administer a test at time 1, and then you do it at time 2, and then you see if there's consistency between time 1 and time 2. These are all different types of reliability is just an example how it's done. So you have your subjects, your initial tests, these are the scores, 12, 15, 22, and then you retest them, you apply it to time 2, and you see there's a change. So the next time is 15, here is 20, is 30, and stuff like that, and then you estimate, the correlation among them. Here is 0.80 or better is always considered reliable, but here is 0.98. This is very highly reliable. That is test retest reliability. We talk about inter-observer reliability. We talk about test retest reliability. And then there's other forms of reliability, split half. Sometimes you divide the instrument into two, and then there's parallel forms where you have a parallel but alternative form of the same test. Remember, when you go to the DVLA or the driving office, they always have parallel forms examination. You take test 1 and you don't make it, you can request for a parallel form. Or as professors, sometimes we have makeup test. Makeup test is not the same as the main test. It's a parallel form of the test. It measures the same thing. If it's a course in research, all the questions measure the same thing. And sometimes they use statistics such as Kronberg's alpha, to estimate, the level of, coefficient among those. Closely related to that, in the interest of time, that's why I'm rushing so that we can have enough time for Q&A, is validity. Reliability means consistency. Validity means accuracy. Remember our scale example. Day 1, I had 80 pounds. Day 2, 80 pounds. Day 3, 80 pounds. So it is reliable, it's consistent. But is my weight 80 pounds? Maybe the scale was not set on 0. So it gave me what? Consistent results. So validity means accuracy, the extent to which measures reflect the true score. So that is the extent to which a measuring instrument measures the underlying concept it is supposed to measure. You can achieve reliability, but without validity. And we look at the relationship between the two. Again, sometimes the extent to which they match, the extent to which they are congruent, or the goodness of fit between whatever instrument that you are using. Now, quick summary of validity, just a reminder. There's phase validity, the extent to which instruments look like they are measuring what they intended to measure. Content validity, the extent to which they are representative. Assuming you gave a test in social research, we've all taken a course in research, and there's topic on research problems, there are topics on ethical issues, there are topics on sampling, there are topics on measurements, there are topics on data analysis. And assuming all the questions are on ethical issues in research, then you can say that this test lacks content validity because it doesn't reflect the entire domain of content. So that is content validity. Criteria-related validity is when you use an external event to assess, something. A good example is a driving test. Sometimes people go for a driving test, and when you go for a driving test and you pass, they give you a license. So your license that you have testified that you can drive. The external event, the criteria here is your ability to drive. Now, construct validity is related to theory. The extent to which measures reflect a particular domain of content based on theory. So that is what it means. So all these have explained. Phase validity is it looks like what it measures. Content validity, the extent to which it reflects a particular domain of content. and then it goes on and on and on. These are additional explanations of content validity. You have access to the notes, so you don't have to worry about it. Criterion-related validity is the extent to which, as I said, you use an external event to predict the later is referred to as the criterion, like the driving test. The ability to drive means you have a driver's license. The driving itself was a criterion that was used to assess your ability to drive. Now, criterion related, sometimes researchers have two types. One is called predictive and the other is called concurrent. Most schools will ask for a test score. If you want to go to graduate school in the US, you need a GRE score. Now, GRE score, a good GRE score predicts your ability to do well in graduate school. So it becomes what? Predictive criterion related. So criterion that is being used here is the GRE or the SAT or the TOEFL. It predicts your ability to be successful. That is a future event. Concurrent is one that is used at the same time, just like the driving test. You drive, you pass, you give in a license. Two types of criterion related. One is predictive, the other is concurrent. All these are examples. There's no time to go over all that, And then the last one is based on theory, as I said, construct. Doesn't measure the intended construct. Doesn't measure what it's supposed to theoretically, measure. There are a bunch of theories. I do poverty research. There's a bunch of theories. Within that, there's a dual labor market theory. There's a human capital theory. There's an individual explanation theory. There's a cultural theory and all that. The extent to which some of these theories predict what I'm interested in studying. That is based on construct validity. Sometimes there are two versions. One is convergent, and then the other one is discriminant. The extent to which two or more theories converge or explain the same thing, or the extent to which they discriminate or they're different. And we know that, we have a bunch of theories, like that. Framework is different. Remember, I use the example of having a room with several windows. Anytime you look in one window, you see a view of the room. It's not the same view, but an aspect of the room. So that could be discriminant, in terms of what you see. Or this is further explanation of construct validity. And this is just a summary of validity, issues. So phase validity, criterion-related validity, convergent validity, content construct is a summary slide of all what we have discussed, on the issue. Now, let me take this. What is the relationship between reliability and validity? We said that the fact that an instrument is reliable does not mean that it is valid. So an instrument that is valid is always reliable. Once you attain validity, then it means you have attained what? Reliability. An instrument that is not valid may or may not be reliable. If an instrument is not valid, it may be reliable or it may not be reliable. So that is one other example. An instrument that is reliable may or not be valid. Sometimes an instrument is reliable and valid, because you need to attain reliability as a first step before you can obtain validity. An instrument that is not reliable is never valid. This is not reliable, it cannot be valid. So reliability is necessary but not sufficient condition, for attaining this. And sometimes we use this example, the first one, reliable but not valid. Reliable, sometimes we play the dots. You go to a restaurant, and there's a dot on the wall they give you to hit the bull's eye. The first one, you did it consistently, so it's reliable, but you're able to hit the same spot. So there's reliability, but it's not valid. Now, the next one is neither reliable nor valid because you are not able to hit, the bullseye. The third one is valid and reliable because you're able to hit the target. In this case, this is a bullseye. So once there is validity, it means you have attained what? Reliability. How do we improve reliability and validity? Several may develop concepts more extensively, improve training for those who will be applying the measuring instrument, interview the subjects with the research about the measurement devices, and use a higher level of measurement. And they use more indicators of a variable, conduct an item by item analysis. All these are examples to improve upon validity and reliability. How do you choose a measuring device? Theoretical relevance, several factors to look at. And then, as I said earlier, anytime you measure, there's always a difference. And the difference is what researchers call what? Error, measurement error. And we will have a short discussion here and we'll stop here for our Q&A because we only have 30 minutes left. Now, measurement errors is what? A difference or variation in responses which cannot be attributed to the variable being measured. Anytime we measure, there is always a difference. That's what we call the theory of measurement error. It's expressed in the formula M is equal to T plus E. M is what is measured, T is a true value, E is an error, which is always as an element. We really never know what the true value is, but then T is always what we try to achieve, but there's always this error element. There are two main types of measurement errors, random and what? Systematic error. When we say something is random, it occurs what? Haphazardly, and that is based on chance. The key factor here is chance. And because it's based on chance, it cancels out and is less likely to affect the outcome of our research. That is why we say it is random. It cancels out in terms of direction and what? And magnitude. So it is less likely to affect. All these are just additional explanations about that. And then there are different types of random errors. One is called transit qualities of individuals. When you are interviewing people, for example, sometimes they are not in the best mood. They are not very alert. They are bored, they are tired. They'll give positive and negative answers, but in the long run, it tends to cancel out, so we don't have to worry. Situational factors are where you do your research. Sometimes the noise level distracts you, the lighting, ventilation, the presence of other people and all that, it all affects. But in the long run, it cancels out. So you don't have to worry about administrative factors. Sometimes we make mistakes, as well. In the long run, there will be high values, there will be low values. It tends to cancel out. So again, based on this, the other type is systematic error. When it says something is systematic, it means it doesn't really go away. It is there, so it consistently or systematically affects the variable being measured. And there are two main factors affecting that. Demographic characteristics. If I ask you about your level of education, you have a first degree and say you have a PhD, it doesn't go away. It's going to bias my analysis, So, I ask you about your income. How much money do you earn per week or per month? And you say, oh, $10,000. Meanwhile, you earn $3,000. It doesn't go away. It's going to bias the mean income for that group or your socioeconomic status and all that. It is systematic. It doesn't really go away. There's also what is called personal style factors. It's a bunch of factors that falls under personal style factors. One is called social desirability, a tendency to give a favorable impression of oneself. Because social desire. If I ask you, how many times do you go to the library? You say, oh, 7 times a week. Meanwhile, you go twice a week, because social desire to go to the library definitely is going to bias our findings. Acquiescence, people have a tendency to agree with statements. When we're answering questions on a scale, like a scale from strongly agree to strongly disagree, sometimes people don't even read the questions. They decide that they're going to check strongly agree and strongly agree throughout, or agree. That is acquiescence. It will affect the outcome, the election deviation. Sometimes people have a tendency to give unusual, uncommon responses. They check the extremes regardless of the nature of the questions. It all affects contrast error. They also tend to rate others as opposite oneself in regard to particular traits. They tend to compare themselves and choose the opposite. Halo effect, it tends then to be unduly influenced by a single favorable trait. Maybe they see an item in the instrument, they're attracted to it, and it influences their other response. It's called the halo effect. Error of leniency, a tendency to rate too high or to always give favorable reports. Some people have a tendency, especially, they fill in a form about, a lecturer or something, and they tend to be lenient. Whatever you say, the lecturer was perfect, strongly agree. The lecturer was fabulous, strongly agree. Whatever you say, strongly agree. So it's called error of leniency. It goes on, error of central tendency. People have a tendency to just stay in the middle. They want to, they don't want to go to the extreme. So you have strongly agree, neutral, disagree, and strongly disagree. So they choose neutral, and it's all the way, throughout, and they choose that. Okay, let me stop here. There's a whole discussion about scaling. Maybe during the Q&A, we can touch on scaling. For social scientists, for physical scientists, for medical scientists, for behavioral scientists, these days, instead of asking simple questions, what is this and this and this, they use a scale. There are people we call psychometricians. Or what they do is they specialize in the development of skills. We have skills in almost all areas in life, name it. The skill is there. You want to study poverty, there's a skill. You want to study anxiety, there's a skill. You want to study whatever you want to study, somebody has developed. The psychometric properties of the skill means the reliability and validity of the skill has been tested. There's a way to score it, and most people use it because it has been verified, and there's a scoring procedure, and people tend to use it. And there are different types. There's a Likert scale, there's a Bugatti social distance scale, there's a texting scale, there's a bunch of scales. It's all in the presentation. In the interest of time, I think I'll stop here, and then we only have about 22 or so minutes so that we can have our regular Q&A, and we'll use that to listen to you, its comments, contributions, and questions. We'll take it from there. So I yield to Chrissy and Irene so that you can moderate the Q&A session. Thank you.
All right. Thank you very much, Professor Dakwa, for that extensive and quality presentation. So we have some questions in the chat board, but we want to take people who would want to make submissions via their microphone. So if you want to make any comment submission, please raise your hand. We'll enable your microphone, and then you take over. All right. So Professor Dr. Birmingham Idrisu is asking, I don't know if that question has been answered. In quantitative study, adoption of already developed questionnaire used by other credible research institutions can improve the reliability of a, I think, okay, that is not a question, it's a statement he's making. That's true. Let me check if there are other. Okay,
but
so
you
Prof,
also have to be mindful of culture. Yesterday, we couldn't have time to talk about cultural issues in research context. So yes, it's been developed, it's been credible, by these research institutions. Is, validity, reliability has been established. But you also have to look at the cultural context. Remember, we talked about clinical trials, how the instrument was tested, the type of population used, and all that. To a large extent, it is true. But always be mindful of cultural context, in administering your instrument. Thanks.
Okay, thank you, Prof. So from the same person, Dr. Birmingham is also asking, can mining data from multiple sources using variety of instruments improve validity and reliability of research? So, Prof, I think you can take that.
Okay. I'm trying to find a question. Yeah, I think, combining data from multiple sources using variety of instruments improve validity and reliability. Yeah, sometimes, remember we talk about discriminant and convergent. Sometimes there are several instruments that measures the same thing, and sometimes people will use them because they want to make sure that the outcome, gives them a higher level of reliable and varied results. So especially when it comes to standardized instrument, there's no single instrument in a given area. They always have multiple, those in the psychological research, the anxiety scale. There are a bunch of them. The study that I am doing now on vaccine hesitancy, I've come across several scales on vaccine hesitancy. I've looked at the questions that they've asked. Most of them overlap. They are different scales, but they are scored differently. The goal is that if you use them, the validity, the reliability has been established. It will help to improve the quality of the data that you collect. So multiple sources, yes, as long as the reliability, and sometimes people use them. In my proposal, for example, I said, I'm going to combine 3 different instruments because they look at different aspects of the same issue. And the goal is to enrich the outcome of the data that I collect. So that is accurate.
Okay, thank you. So there's also a comment from Dr. Abiodun. Some researchers use PPMC to measure instrument reliability. Is this tenable? And if valid instrument is already reliable, then can a researcher just conduct and enhance the instrument validity without reliability?
Well, if the psychometric properties have been established, but remember that validity is a necessary but not sufficient condition, in attaining validity. Reliability is a necessary but not sufficient condition. So if a valid instrument is already reliable, okay, if it's reliable, then researchers can conduct. Yeah, if the validity has been established through all the other aspects, then this is why we use standardized measures, because the validity has been established, the reliability has been established, through whatever statistic, could be through Combes alpha, name it, then we can easily use that. So definitely, yes.
All right, thank you. Eric, you please go ahead.
Okay, hello, Prof. Regarding the question you just answered, I think that once an instrument is standardized, and then perhaps the instrument was developed in another jurisdiction, and then you want to apply it maybe to an African context, is it appropriate that you re-establish its reliability and validity before you use it on the sample? Thank you very much.
Well, yeah, I mean, that is why I talk about the cultural context of research, because the fact that an instrument has been developed in different parts of the world does not mean that it will work, in a different part of the world, because what population was used to validate the instrument? Is it predominantly, Caucasians? Is it African Americans? Is it, so definitely you might, if you're using the instrument, then you have to talk about the limitation of that instrument, the fact that it was developed in a different cultural context, and that some of those factors may not be applicable in your situation and becomes a limitation, of the scale, or you might want to validate it in your own context, by choosing a population, administer it and all that. If you're using it, you always have to note the limitations of the instrument. Those factors are very, very important because, as I said, the context is very different. And the fact that it has worked for population A in a different environment doesn't mean that it will work for population B. So always note the limitations of the instrument, even though the psychometric properties have been verified.
All right, thank you very much, Prof. I think we've exhausted all the questions. The rest are comment. This is from Bumanyeni or Bumanyi Marcella. And standardized instruments may not produce accurate results. Developed in another continent cannot produce, cannot apply in African context very well. Yes, we'll be sharing the slides with you. No problem at all.
Yeah, it's the same thing I mentioned, because you need to be aware of the contra context is very, very important.
Okay, thank you very much, Prof. So we still have some few minutes to go. If you want to make any comments, contribution, ask a question, kindly put your question in the chat board or click on the hand raise button. We will enable your microphone for you to speak. We'll do that for the next 5 minutes. If we don't have any comments coming in, we'll take it as, all right. Dr. Bioden, please go ahead. Dr. Bioden, please go ahead.
But see, it seems Doc is not responding, so maybe we can.
All right.
Yeah.
Thank you.
Move
Okay.
on from there.
I want to appreciate Prof for that excellent presentation. I really enjoyed it. I want to comment on the levels of measurement and the statistical data analysis. When data are collected on the ordinal level and the data are collected at interval level, the kind of statistic that should be used are quite different. Like when we want to compare, we want to correlate the data collected at ordinal level, we cannot use higher statistics like PPMC to correlate data that are ranked, whereas data that are ranked that are at ordinal level, such correlation can easily be analyzed using a lower level of statistics like Spearman rank order. I think these are very jamming when we look at analysis of data and the appropriateness of statistical selection. Thank you very much for the presentation, Sam.
Okay, thanks a lot, Doc, for your contribution. That is why initially I said the level of measurement determines the type of statistic that we can perform on a given variable. Higher level measures, you have more flexibility, you can do a lot. You do, simple regression, multiple regression, t-test, and the rest, name it. But for nominal level measures, you are limited. You can do frequencies and percentages. I think Monday we're going to touch on data analysis. We're going to revisit most of these where we have a data set, and then we use that from data collection using Google Forms. And then while you have the data in Google Form, what do you do with it? You need to translate it from Google Form to something that the software can read. You can export it to Excel or to Google Sheet and clean it, especially using Excel, find and replace function is key. We're going to demonstrate that. And then from there you export it. We use SPSS as an example. We may not have time to look at both qualitative and quantitative. We mentioned qualitative, software as well. We'll do the demonstration using quantitative because I know most of you are quantitative researchers. Then we'll take it from there. So that is the essence of the level of measurement. So sometimes, as I said, you can translate it. If it's a higher level measure, there's flexibility, like the example I gave about, your level of income and your sources of income. How much money you earn is a ratio level measure, but what is your source becomes a nominal level measure. So just, basic statistics can determine that, and we talk about all the different measures of central tendency, measures of dispersion, varied analysis, bivariate, multivariate, name it, depending on how much time will allow us to cover. And of course, you always have access to the lecture notes. So level of measurement or measurement in general is a very, very useful topic. It cuts across all disciplines because the type of data you collect. If the data is weak, of course, your analysis will be bogus. So they say garbage in, garbage out. So we always should be mindful about the quality of the data and how it's measured. If you ask the wrong questions, of course, you're not going to get, the right responses. And sometimes we have jokes, like if you ask somebody, what is your marital status? You expect to say to be married, separated, single, never been married. But somebody will say advanced because they've been married for several years. Or what is your mission? You expect them to say what brought them to your particular place. They say, oh, my mission is Presbyterian, and stuff like that. So what kind of data are you going to get? So all these are examples. Measurement is key. Levels of measurement is key because actually there are tables where they will tell you that if it's a nominal level measure, this is the kind of statistics that you can employ. If it's a ordinal level measure, this is what you can do. If it's an interval and this is a ratio, interval is very close to ratio. The difference is the absolute zero, and that makes the difference in an interval and a ratio level measure. So thanks, Doc, for your contribution. Floor is still open. We have some few minutes left.
Yes, we have about 3 minutes and then we'll wrap up. But Prof. Daniel is saying thank you so much, especially concerning your use of analogies and explaining the concept of sample, and that sampling is a way of life. He's also saying he's impressed. So I think these are some of the comments from the chat. There is not a new one and there is no hand up. So probably your quick last remarks and then we would give the announcement and then we'll be out of here.
Okay, thanks a lot again. Thanks for joining us today. I hope, I know there was a rush at the 11th hour because there was a lot to cover and, you always have access to the slides. And I always say, preaching to the converted, so it's much, much easier. So you can review it. If you have questions and comments, you can always bring them back, during our next meeting. We hope that on Monday you can join us, for the last session, which is actually revisiting most of what we've covered. Because at the data analysis stage, you bring everything together, go through the entire research process because you have your data. You want to make meaning out of your data. After you analyze your data, what do you do with it? You know, publications, presentations, you know, and them. So we thank you for joining us today. And hopefully we'll see you on Monday, God willing. Thanks.
All right, thank you very much, Prof. Thank you to our participants. And so the last session will be on Monday. I put in the chat the payment cost for the certificate. Monday is the last day, and so you can quickly send your payments to us so that we can also compile the certificates that we would have for you. I also want to say that Kwesi would share the slides. Kwesi would share the recordings, especially would be shared when we are done. We'll put it on SharePoint and then we'll give it to you. So Kwesi, please, the last announcement before we go. The certificate goes for $50. I think it's 290 Ghana cedis and then 19,000 Naira. Thank you very much.
And
All
you
right,
can
thank you very
share
much.
the email as well, because I know some people have been asking. That's fine.
Okay, Prof.
Yes. Okay, Prof. Thank you very much, Irene. And Prof, we appreciate your time, your knowledge, expertise, and everything. And our last announcement is that we're bringing you the next session of the professional certificate research workshop, but that will focus on issues concerning publications, article writing. So Prof will bring us that session. We've received a lot of comment. People would want to learn more about publications, why are my papers rejected, and all that has to do with it. So Prof will be with us again to really take us through that model so that from the next sections we'll be writing quality papers and presenting or publishing in high impact journal. So that is the next workshop. But because Monday will be repeating the last model, we are hoping that we'll be able to end the session on Monday. If not, we'll be bringing you the research publication from the 17th to 24th of May. We'll confirm that with Prof and then we'll let you know the final date. So Irene, that is the only announcement we have for you. Thank you.
Okay, thank you very much, Kwesi. Thank you, Professor Dakwa. And on behalf of the Secretary General, I would want to thank all our participants for joining us for these 3 days. The payment information is in the chat. We would add it when we are sending the information for you to join. And so you will get that information from Kwesi. Kindly send us your proof of payment and we can send you your certificate for this workshop. Any other information that we would have, we will send it to you for the next workshop that would be coming up. And so thank you once again for joining us. Have a pleasant evening and enjoy the rest of your weekend. Stay safe. Bye.